Oh, hang on, Mike. Hang on a second there, buddy.
We're up on Facebook.
Yeah, I know, but we haven't shared our sound.
Oh,
Do that again. Hang on a second. Let's try that again. I'll do it this way. And we'll go this way. And then I'll say, I'm going to stop share and go back in again. Here we go. Hey there. Maybe that worked. And somebody said it worked anyway, but oh well,
okay.
we're here.
I said, I think we're up.
That's important. We're up. Hey, good evening, everybody. Welcome back to our Sunday night offering of Astronomy Edutainment, the Sunday Night Astronomy Show.
Yay.
Hey, my name is Chris Kerwin. I'm the creator of the social media channels known as Astronomy by the Bay. I'm also an amateur astronomer and a member of the Royal Astronomical Society of Canada. Now, Paul won't be joining us again tonight, but I would like to welcome back my other co-host this evening, Mr. Mike Powell from the PFO Observatory here in St. John. Good evening, Mike.
Good evening. You almost forgot who I was, didn't you?
Almost. And we'd like to welcome all of you out there tonight that are watching us on Facebook and YouTube, and all of you who are joining us through the local Rogers TV network. Thank you for your support.
Absolutely.
Okay, so on tonight's episode of the Sunday Night Astronomy Show, now many of you have had the opportunity to view some beautiful aurora for the first time over the past couple of nights. Maybe first time for me to see it that stark anyway, for sure. The displays were incredible and at levels not seen really since Halloween of 2003. What's causing all the aurora lately? Is there more on the way? Where should I be? What direction should I look? If I want to view the aurora, what information should I consider before I venture out? Aurora will be our topic tonight, along with showing some sampling of your beautiful photo submissions that came in. And we also have a fine Bino Bud target of the week. And in Paul's absence, I'll be taking a turn offering the another interesting and informative Rosanna's fun fact tonight. So we're going to get started then with turning my phone out of the way. We're going to get started with a talk about the aurora. And I think I'm going to start that one off. So I've got a bit of a presentation here with what I want to talk about mostly. And then about partway through my presentation, Mike's going to jump in with his segment of the Aurora talk. And then I'm going to come back to my segment again. What is the show for tonight? This is what the big question is right now. I'm going to bring up the map here. Second. And let's see if I can share my screen here.
So we're talking posted already that they think it's going to be big. I don't think it'll be as big as it was on Friday night.
Yeah, I don't think we're gonna get that kind of a display. Here's what we see right now when I go to the dashboard of the Space Weather Center, Space Weather Prediction Center from NOAA. And I think most of the apps out there are using their data to predict what we expect to see happen. So what I do is I go in here and I'll go to this one called Dashboards, and I can go to Aurora Dashboard, and it'll bring me up to this. And so here's tonight's Aurora forecast right now. So anything in the red area is pretty well 100% that you're going to see some type of Aurora. And as we get down into the green areas, it gets less and less, but there's still a view line right here, this view line going across the screen that shows you anything above that, you should see something. Right now, it's kind of cutting through the Bay of Fundy for us locally now, and then I can go down here to the Aurora, the 30-minute forecast. So where will the Aurora be in the next few minutes? And there it is. So it's partly through New Brunswick and partly into Nova Scotia, and the probability, I guess, is right around 10 to 20% probability of Aurora at the moment. I always suggest to go in here and take a look at this one, and before you go out to take a look at what's happening, because this gives you the most up to date information. There's a number of things, of course, not just. I mean, this is compiles from a lot of different indicators, factors. So we can go down here to the planetary index, but we'll go over to this side here, the 3-day forecast. Here, these times are in universal time, so you have to take away 3 hours for us. So when it says midnight to 3 a.m., that's really 9 p.m. to midnight. So 9 p.m. to midnight, May the 12th, they're looking at a G3 level, and midnight to 3 a.m., we're still at G3, and then it drops off suddenly, and then it looks like it picks up again. I'm sorry, this is tonight, isn't it? May 12th, yeah. So we're looking at G4 was a little bit earlier, and 5 to 6.67 overnight tonight. So from 9 till midnight of G1 level and a KP of 5, and G3 at a KP of 6 from midnight to 3. So we're going to get into this information, what this all means as well. And we're going to look up here at the solar wind right now is at 820 kilometers per second. The normal solar wind is about 300 kilometers per second. So it's really moving along there. These two numbers here, the BT and the BZ, are the ones we're going to talk about as well. The BT is an 8 as a positive, but it would be nice if it was a lot higher. The BZ is only at a positive 1. We need that number to be a negative before the sun's before that magnetic field coming from the sun, the charged particles will connect with our magnetic field. So the numbers aren't really following true right there, right now. This G4, I don't think it will reach that. But there are a couple of CMEs on their way through, so we don't know when they're arriving. Really, we only know about 30 minutes to 45 minutes ahead of time, because they hit a spacecraft called Discover. I'm going to get out of this right now. They hit a spacecraft called Discover, which is at what they call the L1 Lagrange point. And so it's 1.5 million kilometers closer to the sun than we are. So the solar wind comes in, the CMEs come in, hit that at 1,800 kilometers per second sometimes. So actually, once tonight we're supposed to be. But it takes about 30 minutes to 45 minutes for that wave to reach us from that spacecraft. So that's our first really indicator that something is coming. And then from there, they can predict, yes, exactly, you're going to have this level of Aurora, and the BZ number should follow right along with it. But that's the best we can do. Like we can tell that a cloud of plasma has left the sun. We can tell an idea of the speed of it, but we can't tell the strength of it until it actually arrives. So it's a very difficult thing to predict. It's like I put it up to the fact, like the cone of uncertainty when you have a hurricane coming through. It's going to go 200 miles that way or 200 miles that way. You don't really know until it actually makes landfalls, really, right up to that point pretty well. So we're going to talk a little bit about that tonight, what it all means. And now Brad says the number in the apps I rely on are pretty elevated right now. It will be interesting to see if it holds until dark. There you go. So Brad. So yeah, it will be the idea of keeping an eye on your apps. I suggested a few apps to download there. My Aurora forecast was one of them. Aurora Alerts is another one. Space Weather Live is another one. They're all free apps on Google Play, and you can take a look at the numbers in each one of them, and they're all pretty well within the same. So we'll keep an eye out for that. But I don't think it's at the end yet. The sun released another X 1.5 flare today. That same sunspot. It's twirling around out of the way right now, but there's another big one. Looks like coming right around the corner. So we could be active again very quickly. Okay, so I'm going to stop talking. Imagine. Can I do that, Mike?
Sure.
And I'm going to go to my presentation here. It's just going to come up here on the screen, hopefully. So I'll bring this one. Beginning. Now I have to share the screen. Share screen and screen for.
There you go.
Yeah, okay. All right, so what we're talking about here is solar cycle 25. So solar cycle 25 is the current solar cycle. It's the 25th cycle since 1755, when extensive recording of solar sunspot activity began. Now, it began in December 2019 as we emerge from solar minimum and approach solar 25's cycle 25's maximum. It is important to remember solar activity never stops, really. It changes form as the pendulum swings. Now, the current cycle is actually ahead of predictions, showing that the maximum may now occur in late 2024 instead of 2025. And I downloaded the most recent one here today. So the peak has actually moved a little bit closer to 25 now again, from that last time I had put that presentation on. So we're not quite at solar maximum yet. And look, you can see the activity here is higher than what we had expected. That line is our expected line for solar activity. So it has been very active. Okay. I want to go from there to that one. Sorry, that was the one I was going to show. I'm showing it on my other screen. There we go. Let's go from there into this talk about the solar wind. So the sun sends out a constant flow of charged particles into interplanetary space. That's what the solar wind is. The solar wind ultimately travels out some 3 times the distance to Pluto before butting up against the winds from other stars in interstellar space. Now, the solar wind forms a giant bubble around the sun and its planets, known as the heliosphere. The solar wind is a stream of charged particles known as plasma. It's a state of matter governed by its own physical laws, just as solids, liquids, and gases are. As the solar wind sweeps out from our star, it creates a space environment filled with radiation and magnetic fields that trail all the way back to the sun. And then the other thing that can cause aurora, besides this, there are 2 things that really cause the aurora, or the resultant, I guess, of aurora. Are coronal holes and CMEs. We're going to talk about both of those here in a second. So coronal holes appear as dark areas in the solar corona in extreme ultraviolet light and soft X-ray solar images. Now, they appear as dark because they are cooler. They're less dense regions than the surrounding plasma. Now, what happens here is this open magnetic field line structure allows the solar wind to escape more readily into space, resulting in streams of relatively fast solar wind. And it's often referred to as a high-speed stream, or HSS. And because of their potential for escalated geomagnetic activity and possible storming, G1 levels are higher. Forecasters do analyze coronal holes a lot closer now. And the other factor that we have to consider are CMEs, or coronal mass ejections. They are a significant release of plasma accompanying magnetic field from the sun's corona. Those coronal mass ejections are large expulsions of plasma and magnetic field from the sun's corona. They can eject billions of tons of coronal material into space in one flare. CMEs travel outward from the sun at speeds ranging from slower than 250 kilometers per second to as fast as near 3,000 kilometers per second. The fastest Earth-directed CMEs can reach our planet in as little as 15 to 18 hours. Now, these particles interact with Earth's magnetosphere, and these activities increase with the solar cycle. So the more the increase in solar cycle means more of those happening. Now, everyone's familiar with the changes in the weather on Earth, but weather also occurs in space, much like terrestrial weather. Space weather results from a complex system driven by both the sun and events much closer to Earth. Though space is about 1,000 times emptier than even the best laboratory vacuums on Earth, it's not completely devoid of matter. The sun's constant outflow of solar wind fills space with a thin and tenuous wash of particles. fields and plasma. Now, this solar wind, along with other solar events like giant explosions called coronal mass ejections, influences the very nature of space and can interact with the magnetic systems of Earth and other worlds. Such effects also change the radiation environment through which our spacecraft and one day our astronauts headed to Mars will have to travel. Close to Earth, such space weather can interfere with satellite electronics, communications, and GPS signals, and even, when extreme, utility grids on Earth. And I think a lot of the power companies were on alert the other day, on Friday anyway. Here's a capture of today's activity on the sun. These are sunspots, all of these. This is the one here that was been generating all the interest over the last number of days. It's about to sweep off to the side to get around to the other side of the sun. Over here in this area, looks like there's going to be more activity. There looks like there's a fair amount of activity right here at the edge. So maybe we'll have another big one coming around the corner in the next number of days. So this is the one here that's been generating all the M-class and X-class flares. And here's another view of it with it passing around the edge there. And you can see a lot of these solar prominences or a lot of big loops of plasma that are coming up from one sunspot to another. They're about to come around the corner. So the sun's been very busy. Now, also what can affect what you can see is the moon cycle. Of course, the bright moon can affect whether you will witness aurora, but it's not impossible to witness even with a full moon. What you want to do though is keep the moon to your back, which is pretty easy because you're looking at the northern lights, and the moon is usually, the moon is not usually, but it's always in the southern part of the sky from east to west. So just keep the moon to your back and stand in the shadow of a tree if you can, or another object to maintain your dark adaptation. And here are the moon phases for this month. So we had new moon here on the 7th. Of course, last month on the 8th was the total solar eclipse. So our first quarter isn't coming up until this week on the 15th. And the full moon isn't until the 23rd. Now, what that means for us on the 15th, the moon rises at 2:50 a.m. Oh, sorry, it rises at 12:44 p.m. and it sets at 2:50 a.m. So it doesn't set until almost 3 o'clock in the morning. So it'll be brighter, but it'll also be up a little bit longer. So you'll have to deal with the moon as we move closer to full moon over the next number of days here. So the two things that we talk a lot about are the G level and the KP number. Well, the G and the KP number are just indicators really, or predictions of what might happen. But through some discussion with others and some research, it appears the opportunities to witness Lady Aurora really depend on 4 primary factors. It's the solar wind speed, the solar wind density, the strength of the magnetic field, and the direction of the interplanetary magnetic field. So what are we talking about? First of all, we'll talk about the KP and the G number here. So these are the numbers that when we see the G or 1 or G2 or G3, the G number is the strength of the storm, and the KP number is how far south it should appear. So if we're into a KP of 9 situation, a G5 like we were the other day, they were getting aurora. Actually, we're getting aurora down in Florida, but it should be down around Alabama, that type of thing. So anything above that line would be G5. Anything above that line would be G3. So these are the factors that you want to pay attention to a little bit about. These are the indicators of really what's going to be happening. So talk about those 4 factors. The solar wind is actually a stream of charged particles, mostly protons and electrons that are flowing from the sun. Now, the faster the solar wind is moving, the more likely you are to see an intense display. The solar wind is measured by the Discoverer satellite at the L1 Lagrange point. That is a point in space that's about 1.5 million kilometers closer to the sun than we are. And that's a point at where it's the easiest for the spacecraft to continue its mission and uses the least amount of propellant. That's why it's out there. Now, once the wind reaches that satellite, it's just about 30 to 45 minutes before it arrives here. So that's when we can start to call for the natural predictions. A normal wind speed would be about 300 kilometers per second, but over the last couple of days, they've been upwards of 800 kilometers per second, 3 times the normal speed at times. So the higher wind speeds can cause disturbances in our magnetic field as the wind actually compresses our magnetic field, our magnetic field. So that's what can happen. Now, the other thing that we talk about is the density of the solar wind. Now, the density of the solar wind also plays an important role. The more particles in the solar wind, the more chances we get for aurora display, as more particles collide with Earth's magnetosphere. A value of above 20 part per 70 cubed is a good start for a strong geomagnetic storm, but it is no guarantee that we get to see any aurora, as the solar wind speed and the interplanetary magnetic field parameters also need to be favorable. That's what we're going to talk about next. So what are they? That's the BT and the BZ parts of the components that we talk about. So the BT and the BZ components are also critical to whether we see aurora. The BT is actually a measure of the strength of the magnetic field as it reaches the ACE satellite, also at that Lagrange point. Particles coming from the sun generate a magnetic field. The BT is the measure of the interaction between our magnetic field and the one that's generated by these particles. The BT measures the strength of the interplanetary magnetic field as it passes by Earth. So that's a really critical one. And the other real critical component is the BZ. You can't get aurora without the BZ being favorable. So the BZ is the most crucial component. When the BZ number goes negative, the solar wind that's coming from the sun strongly couples to the Earth's magnetic field. Now you can think of that as a door that allows a transfer of energy from the solar wind into our magnetic field. The more negative the number, the more energy that can be transferred. So the longer the BZ has been negative and the stronger that it is negative, the stronger your chances for aurora will be. The stronger the aurora will be, for sure. So I'm going to stop there. I'm going to get into some aurora prediction sites and apps next. And I'm going to pause there because Mike's going to share his part of this discussion. And here we go.
All right.
Mike?
Hey, part, as they say. We'll get the right screen. I'm just going to talk about a few facts that you may not know about aurora. So number one, people wonder, where do the different colors come from? We don't see them unless you're, extremely up north. You see the green ribbons, but when we were out the other night, we said it looked like white clouds that were dancing around in the sky. But there are colors there because the electrons fall down into the upper atmosphere. So what happens is the oxygen atoms from 800 kilometers, from say around 250 kilometers to 800 kilometers high, the oxygen atoms glow red when they're hit by nearby electrons. They can appear violet due to the mixing of some nitrogen. So that's where you get your reds and violets. And then you get your greens are anywhere from about 100 kilometers up to 250 kilometers up. So you think these things are close to you, but they're not. They're way up there. So the electron ionizes the nitrogen, releasing a blue color. A lower energy electron is released, which then hits the oxygen, causing a yellow-green. So blue and yellow and green gives us that lime color. So that's where you get the lime color in auroras. And then anywhere from 75 kilometers to 100 kilometers high, you get the high energy electrons ionize the nitrogen, giving off a blue color. So an electron is released with enough momentum to excite stable nitrogen, creating a red. So blue and red will give you a pink color. So that's where your colors are coming from and what levels in the atmosphere these colors. And that's why it looks like it goes up in layers from, say, green through red through blue and so on and so forth. A few little fun facts about aurora. Auroras aren't just on the Earth. In fact, all the gas giants have been found to have auroras, and so has Mars been found to have aurora. So it's not just the Earth. We're not special. It seems to be out there quite a bit. Auroras can last for a few minutes, or they can last for several hours, all depending on the strength of these electrons that are coming towards us from the sun. The northern lights happen all the time, not only at night. You just can't see them in the daytime, but they could be happening just like we had the other night. That can happen at 12 noon, and because the sun's up, you don't see them. Now, here's a neat one. There's a new northern light name, and it's called Steve. So now, instead of watching the northern lights, you're going out to see Steve, which is a strong thermal emission velocity enhancement. That's the new name for northern lights. And then, of course, everybody says, well, I can't see color. Well, as they say, use a camera or use the phone camera and take a look through that and take a photograph. You're going to see the colors. That's where they come out, because your eyes aren't sensitive enough to see those colors, but the sensors on your cameras and stuff are. And guess what? You can hear them as well as see them. So for a long time, scientists dismissed the idea that you could actually hear as well as see the northern lights. But recordings made near the village Fiskars in Finland in 2016 proved that around 5% of the strongest auroras do indeed make noise, which is crackling, whooshing, popping, and hissing. These auroral sounds apparently happen when there's a temperature inversion and the electrical discharge in the Earth's magnetic field at an altitude around 70 meters or 230 feet. So yes, you can actually hear some aurora, and that one blew me away. Here's an interesting fact. The first aurora was actually photographed more than 125 years ago. And there's that photograph that was taken of the aurora. It's not digital color and all that good stuff, but someone actually photographed the aurora, and there's an image of it. Now, the earliest documented aurora was found in ancient Chinese text. So the Chinese were actually recording this stuff back, I think, before the, I can't remember the date, it was like 330 BC. But references to aurora have appeared throughout history, even in the Stone Age cave paintings dating back to 30,000 years ago. So even our cavemen were painting aurora on the walls. That's pretty cool. Now, we were out the other night, so I just thought I'd take a few seconds here and throw in a couple of the shots that I got from Florida Beach when Chris and I went out there. And man, we enjoyed the night, I can tell you that. There's a second one you can see as the colors start from green and work their way up through the violets and reds. I mean, it was just an incredible sight to watch. You can see very closely down here, that's Cassiopeia. Over here on the side, you can see is that famous Cygnus that we all talk about. Again, just another shot to show it, it was just an incredible sight to stand there. And everybody that was at the beach was in awe with us. There's one, when we first got there, it was really blasting like right over our heads. And then this next shot was actually taken, that's zenith looking straight up. And it was blue all the way around the edges, and then it moved right to the center. That bright star in the center there is Arcturus, and it was almost at zenith at the time. And man, what a sight. I've never seen. We went out last year and saw Northern Lights, but they weren't doing what they were doing the other night. And I want to just tell you, if you get the chance, go on out and take your camera with you, because auroras are amazing. There's nothing more you can say about it. They just are simply amazing, and you want to take that opportunity when you get the chance. And
Awesome.
that's all I got to say about that.
It's perfect. Yep. That covers it all. Okay. Marianne asked me if I could put the link in the chat. I just did for the dashboard. So if you want to go down through the notes there on Facebook, you'll find the dashboard link there. And Brad says, generally, I've never been able to see color aside from very, very faint green on the best nights. But last night, I swear I could see pink in one part of the sky. It's very bright with the camera. So yeah, it's pretty cool. Sometimes I guess it is possible. Carol asked, could you compare data from Friday night and tonight? Well, Friday night's data, it was a G5 level out of 5, and it was a KP of 8.5 to 9 out of 9. The BZ number, that number I say that has to be in the negative, what I was seeing was down around -40.
Yeah.
Which was about as deep as I don't know how deep it can get, but I know -40 was a good number. The BT number that was really high positive. It was up over 20, which is the strength of the magnetic field as it's coming into our planet. The wind speed was running about 900 kilometers per second, between 8 and 900 when I was watching it. So the typical is 300 kilometers per. So all the factors were favorable for Friday night, completely. And it was, and whether that Friday night event was, what can happen as well is depending on how the material gets released. One cloud could leave at 300 kilometers per second. The one behind it might be 600 kilometers per second. The two of them catch up, and they call it a cannibal CME. So you now have the power of two CMEs coming at you at once, and that's what they think happened Friday afternoon to lead to a Friday night's show. Saturday night, I guess there are more CMEs coming because of the fact that Sunspot has released so many of these flares. That there's actually we released another one today. So there's still a G4 alert level, I'll say, over the next 24 to 48 hours, because when these waves arrive, we really don't know exactly when they're going to arrive. Like I said, until they reach this Discover spacecraft that's sitting 1.5 million kilometers away from us on the other side of the moon. So, well, on the other side of the moon right now, yeah. But anyway, that's the only time that we can predict to about 90% saying, yes, you're going to get this type of level in the next little while. I can look at all these apps and I can see an app like this one where it shows me, shows me data, but I don't know how accurate all of it is. It's something that we have to take into consideration. What I do is I go to that Aurora dashboard and it'll actually show me the oval as it's moving around the planet, or as we're moving around and it's following us. It'll show you the opportunities or the chances that you might have to see it. So, okay, so I'm going to carry on because we're getting a little bit late here. I want to get into our my second part of that talk, and getting into talking a little bit about Aurora prediction sites and apps that I look at. So, of course, that space weather one that we looked at just a minute ago, the Aurora dashboard, is a popular one. And that's where a lot of them get their information from. This is another site that I find that is pretty well updated, spaceweatherlive.com, where they indicate the current values, KP index and the auroral oval, that kind of thing. They also have an app available, but it gives you several screens. The KP index gives you the warnings and alerts coming up, the sunspots that are visible right now, and the KP index. So that's with that app, Space Weather Live, it's called. Another one that is popular is this Aurora Alerts, Northern Lights forecast. And in that app, you can see graphical representations of the values again. So this first one is the speed of the solar wind. The second one is the is that the BZ number, I think? Yeah. And then you've got the BT number and the density. So those four factors are the ones that are going to contribute to these numbers down here at the bottom. And then it'll even tell you the cloud cover in your area, and it'll show you what's expected over the next little while. It'll also show you the aurora oval. These areas are expecting aurora at that time. So that's another good indicator, another good app. The third one I really like too is this My Aurora Forecast and Alerts, which is one that actually does show you the opportunity or the chance for KP in your area, what the levels are, and what your chances are of seeing aurora in your area at that particular time. It'll also give you this cloud of possibilities of aurora, just like the oval does in the other screen. And then the viewing probability, your cloud coverage, and images of the sun presently. So there's lots of that out there. Aurora Labs is another one that I use, that I go to refer to for values. A lot of the same stuff here. It shows you cloud coverage in your area. So that's, go to all those and then go to that Aurora dashboard. That's what I would suggest before going out to take a look at anything, because, and you want to be sure that you're dressed warmly and you're comfortable, and, you got a beverage with you, and you're in an area where you've got cell phone reception, all that kind of stuff as well, right? So tips to viewing the Northern Lights. Well, check out locations on Google Maps first. I get a lot of people asking me, where's the best place to view? Well, I don't know your area. I don't know where you are. Are you in St. John? Are you in Sussex? And I don't know. I know parts of the province, but I don't know the Atlantic Canada area very well. So you know your area probably better than anybody. So I would suggest that you go to open up Google Maps, take a look around. You can put it on Street View, just have a look at what's going to be north, and find a spot that is away from city lights if you possibly can, and that you've got a good view of the northern horizon, because we are a ball, we north, they'll see them overhead, but we might only see them near the horizon. So choose a spot away from city lights with a good view of the northern horizon. And if you don't know what north is, look for the Big Dipper. Check the aurora forecast before you go out, and then check your local weather forecast as well, because that's all going to matter to you for sure. Tips for photographing the aurora using a sturdy tripod. No matter if you're using a phone or you're using a DSLR, use a remote shutter if possible, or set a timer so that you don't hit your button and you're shaking your camera. Make sure your camera has all manual settings on and use them. You need to control your ISO, your shutter speed, and your aperture. If you're using a phone, a lot of phones have night mode on it, and I was using night mode, and that's the picture in my background of me up there was one shot with night mode. Tips that I got from Paul here had suggested, try this. Set your camera on manual, set your camera lens on manual focus, make sure your flash is off. A flash will only pollute your shot, drown out the northern lights, and cause light pollution for anyone else around you. Select an ISO of 800 or higher. The higher the ISO, the lower the quality will be, but with most cameras, 1600 will be just fine. Start with an ISO of 1600 and adjust depending on the strength of the northern lights. Set the aperture to the widest setting, the smallest f number. 2.8 is a good place to start. If your lens has that available, the smaller the f number, the more light that gets let in, and this is your key for capturing the northern lights. Your camera probably won't be able to focus at night, so you will need to manually focus the lens by picking out the furthest thing your camera will focus on. It may be that house in the distance with a light on, or even the moon. You can also set the focus on the infinity symbol if you have one. If your camera has a live view setting, you may be able to switch to it, then zoom in on that point to set your manual focus. Now, lastly, set your shutter speed to somewhere between 5 to 30 seconds. Start with 20 seconds and work your way up or down from there. If the lights are bright and moving fast, you may want to use a shorter time. If they are dim and slow, then use a longer time. And just have fun. Understand that you're underneath, a very awe-inspiring event. It really is free. You really don't need any optical aids at all to enjoy them. If you bring a phone along with you and you take a few pictures, that's great. You got them for memories, but they're just awesome to view. I mean, the best things in life truly are free, in my opinion. So,
Yeah.
so that's that.
A lot of people are still
I'm
asking what
watching.
time tonight. Sometime from the time it gets dark to the time it gets light in the morning. Is all I can tell you.
So if, for instance, right now on one of the apps, I'm seeing an 800 kilometers per second speed of the solar wind. The BZ is only at 3, which means it's not good enough to couple. The density is at 5, which is increasing, and the BT is at 8. So a couple of the numbers are favorable, but not all of them. Although it does say KP of 4. Where is it right there? Sorry.
My guess is
KP
you
of
might be
4.
able to photograph something low on the horizon tonight.
Yeah.
Be my guess.
Yeah. Yeah. I mean, we don't know when this other wave is coming. Again, we only know usually about an hour ahead of time, but there's some of the numbers. Can't really get a good shot of
Yeah, I
that.
can't see the phones.
No. Anyway. Look up the Aurora alerts. That's what I was using to show you just now. And again, Space Weather Live is another good one, and my Aurora
Excellent.
forecast. So there's lots of them out there to take a look at. Make your own judgment. I can't tell you any more than that.
And even they're
And
predicting
as
within
far
a
as
3-hour range, right?
right,
Well,
yeah,
they're predicting a 3-hour range. When people say, "What time should I go out?" Well, no, I'm going to give you a 3 to a 6-hour range that you could see northern lights. Right? It may happen, it may not.
you
I
could.
was most of last
Yeah.
night and got absolutely nothing.
Yeah. And
So-
it can go in intervals too. Like you may see the numbers really good, and it might peak for 20 minutes,
Yeah.
half an hour, and then you might be 2 hours before something else happens, or so there are. It's because it's dynamic and because these waves are coming in. It's waves coming in at you, so you don't know what's going to arrive until it actually hits this Discover spacecraft,
Yeah.
and then you're about 45 minutes away for them to be able to predict something accurate. So,
Like I said in the facts,
your best guess is best.
like I said in the facts, they can last anywhere from a few minutes to a few hours. But it could
Right.
be just a
Yeah.
few minutes. It's you don't know. You don't know until you're out there and you see
Yeah, you
them.
don't know. If you see the signs that are favorable, then and if you've got the time, go out and take a look. And I mean, the worst case scenario is that you're out there underneath the dark, clear sky. So bring along a pair of binoculars and a chair, and while you're waiting, take a look around. There's lots
I
of
had to
stuff to
chuckle
see. So.
because when I was looking up some different facts about Aurora, one of the things was, did you know there's a season for watching Aurora? And I thought that doesn't make sense to me, but then it clicked in why. The winter is because it's longer nights. Well, it's darker longer. So that's why you have a better chance of seeing
Yeah.
Aurora.
Yeah.
From the time the sun sets at 4 in the afternoon, the time it rises at 8 or 9 in the morning. It's dark. So
We lucked out the other night that they were the best
Yeah.
Aurora, like I said, since 2003. So we're gonna get 2 nights in a row. That would be pretty rare to see 2 nights in a row that good. I know that Saturday night they were up around G3 or so for some, and I did have a lot of people that sent in photos for that. So we're gonna try to get to some of them too. Anyway, okay, we're gonna leave it there because next we want to get to a vinyl bud.
not a bud. Nobody's here somewhere. Alrighty. Binocular target of the week this week by Bino Bud is going to be da, 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 Messier 27 or the Dumbbell Nebula? Yeah, that's me. Although
First it is.
M27, the Dumbbell Nebula, is not only the only planetary nebula visible through 10 by 50 binoculars, but it is sufficiently easier to see than others. But you need a larger instrument with some more magnification to actually show some detail and structure. So how would I find it in the sky? Well, it getting darker and darker later and later. So I said, if you go out around midnight and orient yourself 75 degrees towards the east and look up, if you get your binoculars in your hand, guess what? You're going to see what's called the coat hanger is up there. If you come down off the coat hanger, you'll see Sagitta, the two stars together, come to the end of it and go straight up. You'll find M27. That's one way of finding it. Another way is you look up and you see what's called the summer triangle, which consists of Deneb, Lyra, and Altair. And what you do is between Deneb and Altair, you come down about 2/3 of the way and a little bit to the right, and there's M27. You can't miss it. What does it look like? Well, excuse me. This is what it looks like. You're not going to see that in a pair of binoculars, though, because it's very, very small. In 10 by 50 binoculars, excuse me, what you're going to see is a little smudge in the center. Not much to it, but you can make it out. And you can slightly make out that it's a dumbbell. Compared to the full moon, oh, it's the size of one of the main mirrors on the moon. So, you know, it's a good size. You should be able to see it in binoculars. What will they call the first interstellar currency? Starbucks.
Of course.
There you go. And look, I wanted to put a special thanks out to Robert Cadet. He actually photographed last week's Bino Bud target, Napoleon's hat, and there it is.
Awesome.
So thank you, Robert, for photographing Napoleon's hat. And that's Binocular Target of the Week by Bino Bud.
Good stuff. Thank you, Mike. Okay, we're into 8:40, so we want to get into got about 20 minutes left, so I want to get into Rosanna's fun fact next. I'm going to try this one and we'll see how it goes. No guarantees. Let me get this up on the screen here so I can see it. Go to this maybe. Okay, and up and let me share my screen. Oh, share. There it is. Okay. See, Mike. Rosanna's fun fact. All right. Paul has music, obviously, so we can't put it together. But anyway, I'm going to get into this a little bit. So she says, hi, Paul. It's Mother's Day. Behind famous space scientists and inventors, there are usually not so famous moms. But I want to tell us a little story about a space scientist, mom, who isn't famous or well-known yet. Gradually, her history is being unearthed. Now, back in 1921, a sixth child was born to a farming couple in North Dakota. They named her Mary. Mary had bullying siblings and indifferent parents, and so her childhood was a mishmash of existence. When she was 9 years old, social services stepped in, providing her with horse riding lessons and a horse so that she could ride to a one-room schoolhouse. Well, that was quite a beginning. In 1939, she graduated as her high school's valedictorian and was awarded a scholarship for college. She then enrolled at a college in Ohio as a chemistry major. Due to the Second World War and a shortage of scientists, a local recruiter offered Mary a job at a factory in Sandusky, Ohio. He would not tell her what products the factory made or what job would be, only that she would be required to obtain top secret security clearance. Now, short on money, she decided to take a job, even though it would mean having to postpone her degree. The job turned out to be at the Plum Brook Ordnance Works munitions factory, charged with the responsibility of manufacturing 3 explosive okay, here we go. I can see Paul's point now. Trinitolium, I'll call it TNT, there you go, or DNT, and pentolite. The site produced more than 1 billion pounds of ordnance throughout World War II.
Wow.
Yeah, crazy, eh? Mary spent the war years designing explosives for the military, and along with other women, earned the nickname Munitionites. Now, after the war, Mary applied for a job at North American Aviation in their Rocketdyne division. Soon after being hired, she was promoted to the role of theoretical performance specialist, which required her to mathematically calculate the expected performance of new rocket propellants. Out of 900 engineers, she was the only woman and one of only a few employees without a college degree. These two facts were the main sources of prejudice she faced in her time at the company. While working there, she met her future husband, George Richard Morgan, a mechanical engineering graduate from Caltech. Nicknamed Red, he and Mary had 4 children: George, Stephen, Monica, and Karen. The space race was now ongoing. In 1957, the Soviet Union and the United States had set a goal of placing satellites into Earth orbit as part of a worldwide scientific celebration known as the International Geophysical Year. The United States effort was called Project Vanguard. The Soviet Union successfully launched the Sputnik satellite on October the 4th, 1957, an event followed soon after by a very public oops, a disastrous explosion of a Vanguard rocket. Now, until this point, the US had been operating with the assumption that they were technologically ahead in the space race. Russia beating them to it was a source of embarrassment and shifted the US's focus from missiles-based rockets to technology-based rockets. Sputnik orbited for 21 days, showing its success, and in less than a month, Sputnik 2 had also been launched. Now, political pressure forced the US politicians to allow a former German rocket scientist, Wernher von Braun, to prepare his Jupiter C rocket for an orbital flight. Anyone recognize the guy on the left? It's Walt Disney, of course. Now, von Braun had developed the V-2 rocket in World War II for the Nazis. It was capable of covering over 300 kilometers. At the end of the war, von Braun was vulnerable to Nazi violence as they were prioritizing protection of their technology and intelligence, which is the polite way of saying he would likely be killed or imprisoned for his knowledge. He relocated to the United States, but even with the expertise of von Braun and his team, they were only able to get the propeller 93.1% of the way to orbit. The US decided to seek out Mary Sherman Morgan, whose reputation for complex theoretical calculations landed her position of poisoned chalice of finding a better propellant for the rocket. Following the launch of Sputnik, the urgency of the commission intensified. Mary had already created a new propellant a year earlier called Hydine, that had been successful in 3 Jupiter C cone nose tests. Coming up with new propellant, a Hydine LOX liquid oxygen mixture, Mary was the integral factor in creating the successful launch of America's first satellite, Explorer 1, now called Juno 1, in orbit on January the 31st of 1958. There is a hint of the sense of humor Mary had, as when asked what she wanted to name the new fuel, she submitted Bagel to go with LOX. The new name was refused. Mary passed away in 2004 at the age of 82. Sadly, her son George admitted that he and his siblings knew surprisingly little about their mother's life and work when she died. And as she worked in an industry connected to defense and national security, and was limited in what she could discuss. Due to the great avoidance of celebrity attention and status, she never did any interviews in her career or during retirement. She had erased herself from existence, so much that when her son George tried to write an obituary in the Los Angeles Times following her 2004 death, there wasn't enough information to verify her existence. Wow. The newspaper couldn't publish it.
Oh,
Amazing. Now, George created a blog to learn more about his mother and collect as much information as he could. He had built and launched homemade rockets with his friends in the Arizona desert, and as he recalled, quote, "If I had known how much expertise in rocketry my mother had, we could have asked for her to help and asked for her help and saved ourselves a great deal of trouble." George wrote a semi-biographical stage play called Rocket Girl, which was performed in 2008. The play was later turned into a book of the same name. Now, the book was released in 2013, also titled Rocket Girl, and subtitled The Story of Mary Sherman Morgan, America's first female rocket scientist. was particularly hard to source information due to the secrecy of the space race and Cold War relations. So happy Mother's Day to Mary Sherman Morgan, the best kept secret in the space race. And that is this week's Rosanna's Fun Facts.
Wow,
Thank
eh?
you, Rosanna.
Wow.
Awesome.
That's all I can say is wow.
Incredible. A lot of research is put into her topics every week.
Oh, yeah. She does an incredible job.
Only one of 900 engineers. Oh. How do you know if the BZ is heading south? I'm looking at Aurora Alerts app. It should show you that it's a negative. And how it shows that it's heading south. I'd have to dig it out here. I don't know if I have time to do that. Well,
If it's dropping, it's heading south.
yeah, that's right. If it's dropping, it's heading south. It's at 3 right now, so. And the wind speed has dropped to 784. The density's up to 7, so yeah. They're still saying KP8 in an hour, but I don't know. It's all a guess. Sorry, it is. A lot of it is a guess.
Drive to a dark
There's
spot
factors that
and see
lead
what you
to-
get.
Yeah, there's factors that lead to a favorable indicators, but nothing's a sure thing. Okay, but I do want to get to just a few photos that were shared with me before we sign out tonight. And I think I've got some here. Here. So yeah, just I didn't get a chance to capture as many as I wanted to. I ran out of time today. It was Mother's Day, and I had some things I had to do. So, and I don't regret that part. But anyway, I'm just going to share a few of the photos that were sent in, and these are from all over Atlantic Canada. Some of them actually came from other locations. I don't know why they're not enlarging for me. Of course, they come in off of Facebook, so Facebook tends to do this. I'm going to try closing this out for a minute. I'm going to try something else. See if it opens better. Just give me a second here.
So many photographs out there. Like everybody got a chance to see it and photograph it. That was incredible.
That was the best part of the whole thing. I think is that everybody did get an opportunity. And ones who went out, got rewarded by a pleasant show.
Yeah, for sure. You know, those people we met at Florida Beach there, they were like, oh, I've never seen this before. And it's so incredible. And it's like, that's what it's about.
That's what it's doing. Yep.
Of course, you and I were like kids in a candy store too.
Oh yeah, absolutely.
Dancing over our heads, right?
I'm not gonna open up in there either. Hang on a second.
And we didn't even know if we were going to head out. You know, we were texting back and forth. What do you think? I said, well, I'm going to grab a coffee and head towards the airport. And if it looks good, I'll keep going. If it doesn't, I'll come home.
Yeah, we both had to do that. I'm going to share them again, but they are still just coming up. If people send me images through my Gmail address, they come in full size. But if I have to take them off of Facebook, this is what I get. So I end up having to do this a lot for some reason. But there's some pretty nice captures in this group. Go back here one, this one. Yeah, I didn't get a chance to capture where they all were from, but some were coming from Northern Brunswick, some of the better shows, and actually there was a lot from PEI as well. A lot of overhead stuff and a lot of pinks and purples and reds and the colors. Some pretty fascinating stuff. This is a pain to have to do this to every picture, but and most of these are from the Friday night show. There was some that were shown from last night as well. This is out that where we were, Mike. I think someone else was out there, captured that. You're muted there, Mike.
That might have been that group that went right down to the beach.
Yeah, I think it was. Anyway, it's difficult to show in this format. Sorry about that, folks. But
All right, slow down a little bit. I'd like to see them. Flipping through them so quick, it's like wow. It's like
Well,
Yeah, some nice shots. Look at that. Wow.
yeah,
There you are.
yeah. So there's lots of color.
Yeah. And the strength is there. Look at the ribbons.
I mean, nobody saw strength like this before that I can, and not in our area anyway. In over 21 years. So apparently the Halloween night of 2003 was the best, the last best show. And will it happen again? I think we're going to have another opportunity to see this type of show.
Oh, yeah. We're
Our
not
sun is
even at
just
Solar Max yet.
yeah, and all we need is another big sunspot like the one we just saw leaving the sun or going around the corner. Another spot like that, and then we're back into this same
Thing
idea
is that
again.
when we hit solar maximum, it doesn't just stop. It has to taper
Oh
off.
yeah, no,
Right,
that's
so
just the
we're not
it's just
even
the
at
top of
maximum
it
yet.
though.
So,
No, and that may be delayed too. It may be into 2025.
yeah.
And that's another one that, it's an average of 11 years per cycle, but
Oh, that's a pretty shot.
pretty shot there, yeah. It was amazing to see the color that people were picking up. I know a lot of it wasn't naked eye. The greens we could pretty well see naked eye though.
Yeah.
Like the softer greens seem to come. The reds, I couldn't see any reds here. I think Paul mentioned that he may have seen some.
Yeah, I know we didn't. But he's further north than we were,
Hmm.
even though he's up in BC.
Anyway, I want to thank everybody for sending these in. It's awesome to be able to see people sharing
Well, look at
their
that.
images with us. Yeah, that's crazy.
That's another one that was happening right over your head, like straight up.
Right. Yeah. Now this even with some cloud cover there, you're still getting some aurora. Again, I apologize for having to enlarge them like this, but just trying to get a peek at them. There's a nice collage one. And even with the moon up, I mean, they were still getting aurora, right? So what I might try to do is capture more of these, and I'll try to put them up on my page as a video, so that people can get a better chance to see what was involved here. Here we go. Back to start now.
I think it was Kathy Adams. It was cloudy down her way, but she got a picture of the clouds that are red. It was,
Oh, does she? Yeah, yeah.
this is crazy.
That's pretty bright.
That's how intense it was.
Yeah. Does a control plus a zero fix the zoom thing? Sorry about that, Brad. I missed it. Missed your note. Um. Anyway, okay. So I wish everybody good luck. I mean, the next opportunity could be tonight. The opportunities are going to continue, though. I think if it isn't tonight, don't get all sad about it, because we're here. We're into almost solar maximum, and that sunspot was just tremendous. And I mean, 15 times the size of the Earth, and it was just the complexity of the sunspot ended up that we had so many solar flares out of it, not just C's but M's and X's, and the most powerful ones, X4.5, I think, or X5.4 was one of the highest. But then they released these large clouds of plasma. We now know what factors, hopefully, that you know what to pay attention to. The KP and the G are just two parts of the number. Watch your solar wind, watch the density, watch the BT number, wants to be positive, watch the BZ number, wants to be negative. If you don't see the BZ in a negative position, you're not going to see aurora. And that could be in the next half hour, but maybe in an hour's time. Like, there wasn't supposed to be much of a show last night. And I got a lot of people that sent in images from last night. And that was around 2 a.m., which seems to be the time right around between 11 p.m. and 2 a.m. seems to be the favorable time. Of course, it all depends on when it all arrives too, right? But But anyway, I wanted to thank everybody for joining us here tonight on that. Now I can just take a second here. I'm going to try to get something else opened up. And it should be right about here somewhere. I got. Well, we'll pause that. Oh, I love live. Isn't it fun?
Oh, it's the best part.
That's part of it.
Yeah.
Yeah, it is the best part. Okay, well, so that's our show for this evening. Hope you enjoyed the program tonight, and keep the questions coming as far as what's happening with the Aurora. I try to answer as many questions as I can. I can't be online all the time, so I do get a lot of responses that I can't get to. I apologize for that, but try to put up enough information that you can go ahead and make your own decision on where to go, what time to go out, and look at the values, just like I do. I do the same thing. I look at those numbers and decide, is it worth it for me to go out tonight? So I try to present that information to you so that you can take that same educated guess on your own. So, but keep an eye on things over the next number of days because the activity is still ramping up. We're still having a lot happening. They are saying to watch for activity between the next 24 to 48 hours anyway. So keep an eye on that as well. And congratulations to everybody who had a chance to see them, including myself. It was great. So that's our show for this evening. We hope you enjoyed the program tonight. Special thanks again, of course, goes out to Rosanna once again for a fabulous fun facts episode. Thank you, Rosanna. We know there's a lot of work that goes into those offerings for us. And to all of you who share our program out there, thank you very much as well. Remember too, we do love getting your photos, so send them into astronomybythebay@gmail.com. We'll be happy to share them on our next broadcast. I'm a little tired. Tired from the other night, yeah. Special thanks again goes out to our friends at Rogers for joining us again this evening. So until next week, wishing you all clear skies, as we like to say. Open your eyes to view the skies and keep your scopes pointed up. Good night, everybody.